Hi, I'm going to show this paper called Scalable microfluidic droplet on demand generator for non-steady operation of a droplet-based assay. Well, this paper proposed the generation of a droplet on demand (DLT) and in a scalable scale because nowadays with the most um laboratories want to obtain uh, a lot of droplets in on large scale. Well, in this paper, they show that a new model and to produce that. Well, this new device is basically use a microchamber to produce the droplets. Um, it's simple, the application um, of this design, but the problem with in compression that we use the flex is that it has three layers. So um, to explain that in material methods, the device design is making it and with the same programs. And what's the difference? It's with our is the at first the device operation. In this case, they use a pressure flow control MFCS for C 1000 mbar. The fluid jet. In our cases, we use the Adox pumps. In this case, they can connect their pumps to the MATLAB, and then they can automatically control the pressure and and then they do an automatic calculations the mathematical operations to obtain the data for the last statistic. To the base fabrication, they use using lithography, and they use three times uh, treatments to obtain three layers. These three layers they are made with three different steps. We can do that, but we have the problem that with the flex is not that sensible. It's not sensible that the lithography plates, but we can try it. The PDMS mold is the same fabrication, the same experience that we have. For the fluids, they use water for dispersed phase and I'm sorry, the dispersed phase. No, the continued phase, and the dispersed phase is using the HFA oil that we have, the fluorinated oil. And the image acquisition is using this camera oil. And the results in discussions, well, they obtain, they prove with several pressures because they use pressure. In comparison with us, we use fluxes. and they compare the different fluxes to obtain what is the difference between this part. This part is a last chamber. At first, we have the first chamber, the principal chamber here, with the principal flux of the dispersed phase in increasing for this part, and then we have the another flux in this way. So in this case, when you have this chamber fueled by, in this case, oil, then this pressure can um, push this the content of this chamber to the next chamber. Basically, it's not a chamber; it's just a tubing. But the difference in the pressures make that the flux is cutting that we can see here. Yeah. So that's basically the pressure. But they obtain the measure of these droplets obtained is this microtube that is in near for the chamber, and obtain that basically all the droplets was the same. Of all the droplets had the same size. Sorry. And one more. Also, they prove with this design that we have just one inlet and two inlets, because you have every in every side you need to have the inlet of the dispersed phase and the continuous phase, and they use the T and the cross junction, and they have the exit. In this chamber, they obtain the droplets. And how you can see, they prove with different pulses to prove what is the difference between the filling uh, and the production of the droplets. Also, they prove with on the storage design that I saw this design in several papers, but they discuss, for example, the coalescence, and for example, you can see here the coalescence in terms of the light. When you have a lot of coalescence, you have a more darkness droplet. Here you have. And so that's I think that we can use this design uh, to a massive generation of droplets, but also we can prove with this part that I see. Sorry, I don't know what happened here. And when we have uh, in this part, we can separate the continuous phase and the dispersed phase. if you want, because here we have as a design like I don't know what's the word for separated, but I think that if we can prove this, we need to prove with the junction, not with a cross junction, because with the T junction we can use a less oil, or in this case mineral oil, or because we have more distance between droplets, and to store it's better. I thought that's my hypothesis. In conjunction with the new design that we need to prove, that we have the storage, the new design with the storage, we can obtain better results. And that's all. I thank you.